In this video, we are going to discuss about center of mass and center of gravity. The center of mass is defined as a point where we imagine all mass of the object to be concentrated. So if I have a rigid object and there's a point on this rigid object where all mass of the object is assumed to be concentrated, this point then is defined as the center of mass of the object. Now, center of mass for objects which are symmetrical, like a square or a circle or a triangle. So objects which are symmetrical with uniform mass density, center of mass for such object lies at their geometric center. So they will lie at the geometric center of all symmetrical objects with uniform mass density. So if I have a square which is placed at the origin like this, and the length of each side is L, I can locate the coordinate of center of mass to be at the geometric center. So we know that the midpoint on the x-axis, this point over here, will lie at a position of L by 2, whereas on the y-axis, again, the position will be L by 2. So center of mass for any symmetrical object with uniform mass density, the location of center of mass lies always at the geometric center. And for most of them, you can find the geometric center by taking half of the dimension, half of the length, height, or width. Now for a two-body system, a system that has two different objects, let's say an object of mass m1 and an object of mass m2. The center of mass of such object always lie on the line joining the two objects. So center of mass of m1 and m2 will always lie on a line connecting them somewhere in between them. It is always closer to the object which is heavier. So if m1 is greater than m2, center of mass will lie closer to m1 and away from m2. If m1 and m2 were equal, center of mass will lie at a point midway between them. So if both of them had same mass, center of mass will lie on the line joining them, and it will be at a point midway between the two. So these are the properties of center of mass. First, we define center of mass as a point where all mass of the object is concentrated. Then for symmetrical object, it lies at their geometric center. For any two-body system, center of mass will always lie on the line connecting them, and it is always closer to the heavier object. If the two objects have same masses, center of mass will lie at the center of the line connecting them. Let's take an example. In the case shown in figure, what are the relative magnitudes of the two masses m1 and m2? So here you have mass m1 and m2, and they have given you the position of the center of mass, capital M. And we need to find what is the relationship between them, between the mass m1 and m2. Now we have already discussed, if we have two body system, the center of mass lies on the line connecting the two bodies, as well as it lies closer to the object which is heavier. So here my center of mass M is lying closer to the object 1. That means mass of object 1 is greater than mass of object 2. So since mass of object 1 is greater than mass of object 2, we can write M1 is greater than M2. And this is the second option. So second option is the correct answer. If the center of mass was closer to M2, then M2 would have been greater than M1. And if it was at the center, midway between the two masses, then the two masses would have been equal. Now, how do you calculate the center of mass? Suppose you had two bodies or two objects, object 1 with mass m1, and its position vector from the origin is r1, whereas object 2 has mass m2, and its position vector from the origin is r2. How do we find the position of center of mass, which has a combined mass capital M? How do we find its position? Vector R. The center of mass for a two-body system is given by the rule R equals R1 M1 plus R2 M2 over M1 plus M2. So position of center of mass is nothing but the weighted average of the position of two masses. In Cartesian coordinate, you can write the same expression in terms of x, y, and z. So we write x equals x1 m1 plus x2 m2 over m1 plus m2. For y, it will be y1 m1 plus y2 m2 over m1 plus m2. Similarly, for z, we can write z1 m1 plus z2 m2 over m1 plus m2. If you have more than two objects, then you will just add one more object here where you will write plus x3 m3 over m1 plus m2 plus m3. No matter how many objects you have, you can just keep adding them in the numerator and denominator to get the position of center of mass. Problem based on calculating the center of mass I have discussed in my other videos. So if you want to learn how to use this rule, please refer to the videos of chapter 8 to understand how we can apply this to find the position of center of mass. Now, what is center of gravity? So center of gravity is a point where we can imagine the force of gravity acting on the entire object to be concentrated. So again, if I have a rigid object and I take a point on this rigid object such that the entire force of gravity acting on this object is concentrated, then this point is considered to be center of gravity. Now, since center of mass is defined as a point where all the mass of the object is concentrated, that will also be the point where the entire force of gravity is acting on that object. Because force of gravity acting on an object is the weight of an object. And weight of an object will be concentrated at a point where the mass is concentrated. And where the mass is concentrated, that point is your center of mass. So in objects which are not very large, center of mass and center of gravity generally coincide with each other. So I can consider this point as center of mass, and this will also be the center of gravity for the object if this object is not very large. So they are terms which can be used interchangeably, center of gravity and center of mass.